This video it's about a problem on polynomials. We are given the polynomial p of x, and they say that when it's divided by x minus x plus 1, the remainder of the division is equal to 4. When the same polynomial is divided by x minus 2, the remainder is equal to 4 again. This polynomial p of x has degree 3, and x minus 1 is a factor. The leading coefficient is 1, and p of x, they ask you to find p of x. This is the capital P. So they ask you to find this polynomial. Okay, the first piece of information that is easy to use is the degree 3 perhaps. So a polynomial of degree 3, it's automatically written as ax3 plus bx2 plus cx plus d. This is a polynomial in standard form going from the highest power to the constant. Now the second next piece of information that is easy to implement is the leading coefficient is equal to 1. Now the leading coefficient is the constant that comes with the highest power. So it's equal to 1. So we write p of x is equal to x3 plus bx2 plus cx plus d. So instead of working with trying to find a, b, c, d for unknown, we are looking now to find these three unknowns only. The next thing is they are talking about reminders. So talking about reminders that tells us that we might need the reminder theorem. So review of the reminder theorem. The reminder theorem tells you that if you have got a polynomial p of x divided by x minus k, a linear polynomial x minus k, the remainder of the division will be p of k. This k and this k are the same. Good. So let's use the first piece of information. Now p of x divided by x plus 1. I'm using this information here. The remainder is 4. So the remainder is equal to 4, but according to the theorem, it's equal to p of minus 1. Now this is k, x minus k. So k is equal to minus 1 when you compare plus 1 with minus k. The second piece of information, when p of x is divided by x minus 2, the remainder is 4. So p of x divided by x minus 2, the remainder is equal to 4. According to the theorem, p of 2, k equal to 2. This is k, x minus k, so k equal to 2. Now factoring. So we review again factoring. Now if I tell you that x minus 1 is a factor of px, that means that I can write p of x as x minus 1 times a certain polynomial plus, with remainder equal to 0. This is very important. Factoring has to do with remainder equal to 0. So now if the remainder equal to 0, the remainder is equal to 0 when you divide p of x by the factor x minus 1. So again here we go and use the remainder theorem. So if I divide x by minus 1, I have a remainder equal to 0, and according to the remainder theorem, this is equal to p of 1. This is x minus k, remember, k equal to 1. So let's put all this together, yeah? So we have 1, 2, and 3. These are going to give us the equations. Now let's put them here first. So P of minus 1 equal 4. P of 2 is 4. And P of 1 is equal to 0. We now write the equations. So P of negative 1, you just substitute x by negative 1 into the equation of the polynomial. So negative 1 power 3 plus b plus d. All what we did is x equal to minus 1 and use the bracket to avoid mistakes in the sign. Now P of 2, the same thing. You just substitute x here by 2. Of course, this is equal to 4. This is also equal to 4. And P of 1. So you substitute again x here by 1. And it's equal to 0. We need these three equations. This is a system of equations. We now simplify the equations starting with number 1. So we have minus 1 power 3, minus 1 power 2, and so on. These are written as minus 1 power 3. That gives me minus 1. And then plus b, because minus 1 power 2 gives me 1, minus c plus d equal to 4. And then I will have here 2 power 3, 8, 2 power 2, 4. So 8 plus 4b plus 2c plus d equal to 4. This is equation number 2. The third one will be 1. 1 to the power 3 is 1. Plus b here. Plus c plus d equal to 0. Now we rewrite the equation in standard form. In the system of equation, we put all the constant on the right. So let's write them as follows. B minus c plus d equal 4 minus 1, that gives me 5 here. And then the second one, 4b plus 2c plus d. 4b plus 2c plus d will give me 4 minus 8, that gives me minus 4 here. And then the last equation, b plus c plus d equal negative 1. Now let's call them again 1, 2, and 3. Doesn't matter for the numbers. And then start solving. Now when I examine the three equations, I notice that this is b here and b here, d here and d here. So a simple subtraction will give me an equation in one of the variables. So let's do equation 3 minus equation 1. So 3 minus 1, b minus b 0, c minus c 2c, d minus d 0, minus 1 minus 5, that gives me minus 6. And then this gives me c equal negative 3. So we know we have one unknown. Now what we do is substitute c equal to minus 3 into 1 and 2, because we have used 1 and 3, so now we need to use 1 and 2. So 1b minus c, that gives me plus 3. Yeah, c equal minus 3 here, that gives plus 3, plus d equal 5. Then the second equation give me 4b. Now I have 2c minus 6, 2 times minus 3, plus d equal minus 4. Now simplify a little bit more. B plus d, The first one give me b plus d equal to 5 minus 3. And then the second one give me 4b plus d equal minus 4 minus minus 6. That give me 2. Subtract this from this. So 4b minus b, 3b. D minus d 0, 2 minus 2, 0. That gives me b equal to 0. So c equal minus 3, b equal to 0. Now if I put b equal to 0 here, that gives me d equal to 2. And that's it. We have our polynomial. Remember our polynomial is px. P of x equal x3 plus bx2 plus cx plus d. We substitute bcd. B we said equal to 0, so this term will go. C equal minus 3 and d equal to 2. This is the polynomial we're looking for. We can easily check dividing p of x by x plus 1 to find the remainder 4, and also dividing p of x by x minus 2 and finding the remainder 4. X minus 1 is a factor because p of 1, if you put 1 here, you get 0. Now, in the first part of the video, we have used the methods of the remainder and the factoring to solve the polynomial. Now, we're going to solve it again in slightly different, slightly faster method. So we're going to say that since x minus 1 is a factor, we can say directly that our polynomial p of x is equal to x minus 1, which is a factor multiplied by certain polynomial. Now, the certain polynomial can only be a polynomial of degree 2 of the form, of the general form ax2 plus bx plus c. Now, let's use this information, the leading coefficient. When we expand this polynomial, this x with ax2 will give us the term ax3, which is the degree 3, which indicates the degree 3. And because the leading coefficient, now plus other terms, of course, with a lower power in x. So this is the highest, and this will be the leading coefficient, and of course it's equal to 1. So p of x is written as x minus 1. A is equal to 1, so directly here x2 plus bx plus c, and therefore we have only 2 unknown to find instead of 3 or 4. Now for the rest, we are going to use the same ideas of the factor theorem. So if you remember, p of negative 1 is equal to 4, p of 2 equal to 4. This comes from the division by x plus 1, x plus 1 and x minus 2. So p of negative 1, we go here and we put x equal to negative 1, go here, x negative 1 power 2 plus b multiplied by negative 1, which is our x, plus c, and this equal to 4. So 4 here. Second one, p of 2, we go here and we put x equal to 2 here. So 2 minus 1 multiply 2 power 2 plus b multiplied by 2 plus c equal to 4 again. So we have 2 equations, 2 unknown, capital B, capital C. Now let's adjust this here. Good, so let's call them equation 1 and 2, simplify them. When we simplify them, they are written as, so simplify here, this is minus 2, and then here 1 minus b plus c, this is a plus here, bracket equal to 4, and then 2 minus 1, that gives me 1, so we end up with 4 plus 2b plus c equal 4. Now the top one can be written as negative 2 plus 2b minus 2c equal 4, and the lower one will be written as 4 plus 2b plus c equal to 4. Let's call them 1 and 2 again. And then let's do 1 minus 2, equation 1 minus equation 2. That will give minus 2 minus 2 minus 4. That gives me minus 6. 2b minus 2b, 0. Minus 2c minus c, minus 3c. 4 minus 4, 0. The constant term. 4 minus 4. Yeah. Good, so we solve this. That gives me minus 3c equal to 6 and c equal minus 2. Now c equal minus 2, if I substitute in one of the equations, let's substitute in this one here. So 4 plus 2b. Okay, we are substituting here c by minus 2. So 4 plus 2b. c, it's minus 2, that gives me 4. And then I solve 2b equal 2 and b equal to 1. Now our polynomial is written as x minus 1 multiplied by x2 plus bx, b equal to 1, c equal minus 2. Now let's expand the right side and compare the results with what we found in part 1, in the first part of the video. So that will give me x by x2, x3, and then plus x2, and then minus 2x when I multiply here. Now minus 1 by x2 minus x2. Minus 1 by x, that gives me minus x, and then the last term minus 1 by minus 2, that gives me plus 2. Now we group the like terms. x3. Now x2 minus x2 goes, minus 2x minus x minus 3x plus 2. And this is exactly what we found in the first method. Now the second method might be a little bit faster than the first one. And the thing about this problem is that we have reviewed quite few concepts about the polynomials, the degree, the leading coefficient, factoring, remainder theorem, and so on.